There.
Hello? Hello, how are you?
Hello. Hello. How are you? Fine. What's about you?
Fine, 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 fine.
Fine. Fine. Fine. Fine.
It's good to see
Nice.
everybody once
It's good
again.
to see everybody once again.
Good to see you too.
Great. So,
Yeah, good to see you.
yeah, let me
Thanks.
ask you, are you currently observing the lunar eclipse? Are you currently observing it? Everyone's got quiet. All right, so congratulations on your success on the asteroid search. So right now we can move over to the exoplanet search. I hope you can hear me. My network is out.
Could you repeat?
15, I think.
Okay, sorry, what did you say? What did you say?
I
I can't hear you. Hello? Oh my god, the network is bad.
this is the question.
Your line is breaking. I can't hear you.
He said that we will see the eclipse moon, the moon eclipse after 1 hours.
Okay, okay.
Okay. Okay.
All right.
This is your
I
question.
Right.
So
I was actually
I was actually.
observing it, but because of this meeting, I have to cut it short. So no problem. I want some other people to join us, so I want to send them a message. Just give me a second. If they are able to join us, they can join us. Give me a second. Exoplanet is calling. Okay. All right. So, all right. Now there are two parts to this. There are two parts to this training. We have the lecture part where I'm supposed to teach you everything about this project, exoplanet search, and then we have the training part where you start analyzing the data. However, I discovered that if I start with the lecture part, some people get bored. Okay, so I want to start from the training part. Okay, so as the training is going on, maybe after the training we can go into the lecture, or maybe I can recommend the recorded video of the lecture to you later. So do you accept? All right.
All
So
right.
great. So let me share a document with you. Let me share a document with you. Just a moment. So in case if anyone comes in, just accept the person. I just sent the invitation for some of our other colleagues to join in if they can. So please open that link. Open that link. It contains all the links that we are going to be using for this training. All the links. Okay. So I'm going to be sharing my screen too, so that you'll understand all my explanation. So you can open the link in your computer. Let me also share my screen so you see everything I'm doing. Share. So this is the link. Okay. Now, before now, I sent you a message, right? I sent you a message and I told you that I told you uh, about some requirements, right? I said you should send it to your team members. Did you do that? And I told them to generate their own observation code. Did you do that? Hello? Did you generate the observation code? Did any of you generate the observation code?
Not yet.
Okay, we can do that. We can do that. But I want to know if all of you have Gmail account.
Yes.
Great, great. So
Yes,
let
we
us
do.
let us first of all start with the observation code. It is very important for us to use to submit our report. Okay, so sorry. So come over to this number 3. Link to register at the ASVSO. Okay, that means the American Association of Variable Star Observer. So you click on that link. Okay, you open it. So I want you to do the same. So we want to create a new account. Okay, I want to create a new account. Use your email. Maybe you can use your Gmail username, first name. You can skip this one. Let's focus on the ones that have asterisks. Those compulsory ones, the red asterisks. You can skip these ones. Later, you can come over and fill up the space. Then after filling it up, you come over to this. You indicate you're not a robot. Okay, then it will give you some patterns to identify. Then after that, you click create new account. So once you have done that, it will send you a message to your email. Okay, it will send you a message to your email. Then you click that link to confirm. Then it will log you in into your profile. So when you are logged in, I want you to let me know. So do this and give me your progress. I hope you are doing it.
Okay, we will do it.
Yeah, I'm waiting. I'm waiting actually because we need it to proceed. We need it to proceed. So
Okay, we wait a few minutes.
yeah, I'll give you all the time. Yeah, I'll give you all the time you want. So fill up those compulsory spaces. Leave those ones that do not have the red asterisk. Later you can fill them up. Focus on those ones with red asterisks. After that, you click I'm not a robot. Okay, indicate you're not a robot. Then it will give you some some patterns, maybe bridges to identify or animals to identify. Then after that, you you create new account. So when you do that, it will take you, it will refer you to your email to confirm your login or your registration. So when you click on that link, it will confirm your registration, also log you into your account. And once you are there, you let me know. And maybe one person should share his or her screen so that we can learn from the person, learn the progress. Okay. At least if you make a mistake, I can correct you. Another person will learn from it. I hope you understand. Oh, great. Great, great, great. All right, set password. Okay, maybe you have gone through the first part. This is a one-time login for you. Click on this button to log into the site and change your password. Yes, this. Okay, yeah, do that, do that, do that. You have just used your one-time login. Okay, okay, you have been logged in, right? Okay, you can fill up these spaces. Yeah, fill up these spaces. Fill them up. Yeah, fill them out. Fill them out. Fill those red, oh, those red compulsory. Okay, yeah, you are okay. I think you have done that. All right, come down, 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 down. All right. Uh, okay. I think yours is not English. Wow. Just save, save, save. Click on save.
Okay.
Okay. The changes has been saved. All right. So click on my account up. My account up, up, up. My account. Yeah. All right. Now you see that you see you have AAVSO observation code. You have not generated it yet. Now to generate, I want everybody to pay attention here. Okay. I believe everybody is at this page. So click on profile so that we can generate it. Click on profile. Yes. Reload or whatever.
Yeah, wait a minute. Because
Okay. Go back. Maybe you should go back. Okay. Click on profile again. What's going on? Why is it not showing the profile? Ah, this is strange. Quite strange. Okay, another person is okay. Another person. All right. Okay. Now, when you click your profile, come over to personal information. There is a hyperlink there to generate your observation code. Did you see it? I hope everybody is seeing that. Under personal information. Yes, yes, exactly. Click on that. Click on that. Good. So what did it say? You have been assigned an observation code. And what is the observation code? Can you see that? Under personal information, come over to personal information. There is a code there. Hope you can see it. Yes, yes. Now click on home. Click on home. Just click on go to home. Home. Go to account. On my account. So you see that your observation code has appeared there. So you have to memorize it. It is unique for everybody, okay? My observation code is different from yours. See this observation code as a registration number, like university registration number, and it is unique to everybody. Do you understand? So now you have done that, you have passed the first test. So who else is still stuck? Who else is still stuck? So if you have generated the observation code, you have passed the first step. I hope all of us are on the same page. Okay, if you keep quiet, it means that maybe everybody is all right. So we move over to the next step. You can stop sharing. Let me continue sharing. Let me continue sharing. So the next thing is you come over here, link to practice data set. We're going to use this for practicing, okay? We're going to use this for practicing. So click on it to download the content, the image set. So there are 3 image sets there. We're going to use it. Maybe we can use 2 for tonight, okay? We can use 2 for tonight. But just download the 3. They are not big, okay? I think one is just 23 megabytes, just one of them. So 3 of them should be 60 something megabytes. So click, if you want to download, I think you come over here, you click on, okay, download, okay? You begin to download. After this one, come over to this, you download this one, okay? So you do it for the 3 folders. Now, if you go over to your after downloading the 3, if you go over to your download, you will see the folder. Okay, this is my downloads. This is the folder I put the 3 of the 2. I think the 2 of them. I have only 2 here, but no problems. Even if you download the 3, you can use the 3 later. Okay, so this is the folder where I have the 3 folders. Okay, and if you observe, just like in the Isaac folders, they are zipped. Do you understand? So you have to unzip them. If you want to see the content, you have to unzip them. And you know how to do that. You extract. You extract the files. You extract the files. So let us see the images inside. Want to see the images inside? Okay, I extracted the first one. Okay, these are the files. Okay, excluding this folder. Okay, I want to exclude this folder, and I want to also exclude the readme file. Okay, let me remove this. Now, if you exclude the 2, so you have how many images there? You have about 67 images. But you know, in Isaac we have about just 4, but here we have about 67. We are going to be analyzing these images, but we're going to use a special computer program to do that, okay? So they're going to do it one by one. It's not stressful. So if you have downloaded the folders, I think you have passed the second stage, the second test. If you have downloaded this, I think you have passed the second. Now the third is now let us go and start exploring. Come over to number 4. Come over to number 4, exoplanet project. Click on it. It will take you to the NASA website. Okay, to take you to the NASA website. There are many options to explore here, and maybe you can do that later. Do you understand? There are many options to explore here. Many how to participate. This one. There are many options, but one thing I want you to do for me is I want you to log in into this Slack up here. I want you to log into this Slack later, not now, okay? In this Slack, you're going to meet the NASA community that are involved in this. You're going to meet with the NASA team that are in charge of this project. Do you understand? So you can do that later, but in fact, this night you're going to do that because it is very important that you share your light curve with them. You're going to share your light curve with them. So there are many important information here. Okay, if you want to be getting the newsletter, monthly newsletter, you can put your email. That is much later. Okay, you do that much later. We don't have much time for that. Okay, so but most important thing, you must get into their Slack channel. You must be part of that community. All right. Now, come over to exotic. Come over to exotic. Click on exotic. Please, if you are behind, you have to, call my attention back, okay? If you leave me, I will continue going on and assuming that you understand. All right, so we have the exotic. The full meaning of exotic is exoplanet transit interpretation code. It is actually a Python code. It is a it's a program written in Python, okay? But you don't need to have the knowledge of Python to operate it. You just click buttons here and there. Do you understand? So don't be afraid. Even if you don't know Python, you are going to make a lot of contributions too. So here there are three stages. We have the beginner's tutorial. Like you are a beginner, I'm going to start from here. When we have finished with here, we move over to the standard. Okay. Now we also have the advanced, but they are the same thing. In this program, there are two ways of getting data. You can get your own images from your own telescope. Okay. If you get your own images from your own telescope and you want to analyze those images, you use the advanced. But if NASA gives you images, maybe you requested for images from them because maybe you do not have access to a telescope, you use the standard. Do you understand? So, but for most cases like us, we do not have. I would just assume that we do not have our own telescope. So, we are going to be requesting data from NASA, and we are going to be using the standard version. So, let us start for the beginners tutorial first, and then after that we come over to the standard version. So click on this beginners tutorial. It will launch you to the exotic program. Now this exotic is mounted on the Google Colab. Okay, it is mounted on the Google Colab. And the process of what we are about to do now in astronomy, it is called reduction. Okay, performing reduction. In performing reduction, you do a photometry of all the images that you have. Now, in this beginners tutorial, images have been loaded for us automatically. Okay, it is just like giving you a gun that has been loaded with bullets, and I say shoot. Do you understand? It is different from not loading it. Okay, I can give you the bullet, and I can give you the gun separately, and I say load and shoot. Do you understand? That is for the standard version. But for this beginner's version, the bullet has been loaded for us. And that planet is HAT P32B. Okay? So these images have been loaded for us. And bearing that in mind, you might want to read some information here. So we want to find the target planet. So you can come down to step 1. Step 1 says load telescope images. Okay, we want to load the telescope images right now. Okay, so if you come down a little bit, you will see a button here. Okay, you see a button here. I want you to click on that button. Click on that button. So it said warning, this notebook was not authorized by Google. No problem, just come over here and click on run anyway. And you would notice that it will begin to read something. So what is going on now, it is because I told you don't need to install anything. Everything is online, okay? What it's doing now, it is trying to load all the Python packages that it will use to run the images. And I think it has, okay, it is still running it. Okay, it might. No, we are not in step 2 yet. We are still in step 1. So you see that important libraries. Okay, this will take up to a minute. Please wait. It's running. It is important astropy, SkyPy. Okay, loading telescope images. So many things are going on here, and now it has finished. So 50 seconds completed. Okay, so and how do you also know that it has finished? If you come over here, you will see a green mark showing that you have finished, and also you will see an indication that you should move over to the next step. Okay, so this is also an indication that uh, your images you can move over to the next step. And also observe that you have 142 telescope images in this loaded. 142, okay, has been loaded. Sorry you can't see it, but believe me, it is there. Now let us go to the next step, which is step 2, and that step 2 is to identify your target star and the comparison stars. And what does that mean? Don't worry. So, if you don't know what it means and you are a beginner, you can watch this video by just clicking here. Okay? You can watch this video by clicking here, but I wouldn't want you to do that because that is exactly what we are going to do right now. So, let us identify the target star. Okay? So, this is our target star. Okay? Hat P32. And this is the telescope that observed it, the micro observatory. That is the name of the telescope. Just come over here and click. So something happened. Okay. Something has happened. So we want to identify our target star and our comparison star. Now, what is this on your screen? Now, this is called a star chart. The star chart of the patch of the sky where you can find this star. This star. Okay. So assuming that I say you should observe Polaris, okay, the northern star. If you point your telescope to the northern star, you can't capture only the northern star. You also capture other stars in the background, okay? We call that the star chart or the star field. Do you understand? And your target star is this cross at the center. That is where your target star is. It doesn't matter whether it is pointing at something or not, because if you look at that star chart, it is not pointing at anything. Okay, it is not pointing at anything. So, but we're going to use this star chart to identify this star here. To identify this star right here. Okay. So, what we need is what we call pattern recognition ability. Okay, you should be able to identify patterns. Now look at this chart very well. You will notice that some objects are bigger, okay, than others. Okay, those are stars that are pretty bright. Okay, and if you also observe, some of them have numbers. They have numbers. Those ones with numbers are the ones we call the comparison stars. Okay, comparison stars are stars with known brightness. They help us to uh, identify the target star. Okay, the target star is the one that we are concerned with. So those comparison stars are very important. Now we want to look uh, at this pattern. Look at this pattern here. Can you also identify it here? Can you identify it here? Meanwhile, I want to also show you some functionalities. So here, here you can zoom in. This is a zoom. Okay. Maybe you want to zoom in into, okay, I have clicked on that. Come over here. Maybe you want to zoom in here. You hold down the left click button, you highlight, then you zoom in case you want to zoom in. If you want to reset it back, you come over here, reset. Okay, so now, right now, what is most important is for us to identify this pattern. Can you look at this? Can you look at, and please observe that something is going on as you are moving the mouse, the cursor around the images. These are your images that have been loaded. As you're moving the mouse, you will see two Cartesian coordinates, the x and the y. Okay, x and the y. These are the location of these stars in the Cartesian coordinates. Do you understand? So I want you to look here. Okay, look at this. Can we identify anything that goes in this form? Okay, it starts like this and goes in this form, and maybe it stretches to this and goes up. Can you identify it here? Okay, let me help you because this is your first time. So if you observe all the stars in this star field, you would notice that something similar is happening here. There's something similar happening here. Okay, so look at that. Look at that. It is a little bit bent here and here until you reach here and you go like this. So look at it. It is like this. Okay, until you go like this. So I think that region, this region here, this region here looks like what we have here, and very close to this star is where we have our target star, because our target now is to get a target star. So let me zoom in onto this region. So I like to use this because I'm using the wheel mouse. Okay, I'm using the wheel mouse. I'll come over here and I will zoom in. I will zoom in. Okay, now look at that. I want you to believe me that there are two stars here. There are two stars here. There's another bright star here. This is the star. This star here is also this star here. And this star here is this star here. Okay? If you take it higher, you can also believe me that this star here is also this star here. And this very bright star here is this star here. So you can recognize this pattern. Please, I want you to respond if you are getting what I'm doing and what I'm saying here. Are you getting what I'm saying? Respond.
Yeah.
Yeah,
Yeah, yes.
can you please repeat the last one?
Okay, what we are doing now is pattern recognition. Pattern recognition. So let me start. Let me reset it. So when you look at the pattern of stars here, okay, what is required of you is to identify the pattern here. If you identify the pattern, it will help you to narrow down on your target star. And I have said the target star is this one, this cross here at the center. It doesn't really matter whether it is pointing at something or not for this star chart, but in the image there must be something it is pointing to. Okay, so and I'm telling you right now, I want to help you. Okay, and I said if you observe around this region, there is similarity between these here and here. Okay, now to narrow it down further, I will use my mouse. You might, if you don't have this mouse that has wheel, okay, if you don't have the mouse that has external mouse that has wheel, okay, you can use this one. Okay, let me assume that you don't have the mouse. I want to zoom in. I'll come over here and the box zoom. I'll make sure I highlight it. Then I will start from here. I will hold down the left click side of the mouse. I'll hold it down. and I will drag. I will drag it, okay? I have dragged it, so I have zoomed in. And if you observe again, you would see that, look at, there's a pattern here, okay? So like I'm telling you, this star here, these two stars are these two stars, okay? This bright star is also this bright star, okay? This one here is this one. So, and which other one? I think this one should be this one, okay? And this bright one here should be this one, and this very bright star here should be this one. So it means that our target star is in that region. Now, now we have identified the region where our target star is in the image. And I want you to also observe that the target star isn't at the center of our image, okay? So that you don't fall into the mistake of looking for the target star at the center of the image. No, the target star can be at any part of this image, okay? So the first thing you should do is to identify the pattern, okay? From here, identify the pattern. Once I've identified that, you can then start looking for your target star. Now, let me zoom in again. Let me zoom in again into this region. Okay. All right. Now that we, so this is the brightest star closest to our target star. So, and if you project any bright star, any star that is very very close to this bright star should be our target star. Okay. Now, this is that star. Okay, this is that star. So if we project, okay, if we move forward, it means that this star is our target star. So we have identified our target star. So you bring your mouse right on top of that target star and copy down these coordinates. So, you know, as part of the instruction that I gave to you, I said you should come with paper and pen. So copy out that target star. So I have paper with me here. Oh, I have removed my mouse, sorry. So I'll bring it right there. If you observe, there are parts that are whole numbers and there are parts that are decimals, okay? Just copy the whole number part. You may not really want to approximate. Just copy the whole number part. So my target star is X. Oh, I've removed this. Oh my God. My mouse is disturbing. Let me do that again. Alright, so my target star T, the S coordinate is 4, 2, 3, and the Y coordinate is 286. 286. So I have written down my target star. Now I would like to find my comparison stars. Comparison stars are those stars that have numbers on them in the star chart. So what are the comparison stars? So you might want to, find two comparison stars, okay, between 2 to 10, okay, between 2 to 10. So now this one has a number, okay, and this one has a number, and this one has a number. So I'm going to use these three. I'm going to copy it. I'm going to locate them in my images and copy them down. So I'm going to use them as my comparison stars. So here, this one corresponds to this star. So this is this particular star. I'm going to write it down. So the comparison star is CX. For the first one is 490, and the Y is 304. So that is for C1, the comparison star 1. The other comparison star is this one, and it corresponds to this. So I'm going to copy down the x coordinate is going to be 415 and the y is 343. So that is for the other. Now for this other one, for this third comparison star, this is it. This is it. Okay. Now C3, that is my comparison stars 3. The x coordinate is 326 and the y coordinate is 365. So once you have copied down your coordinates, you can come over to the down part and write it down. So it said enter coordinate for the target star, and this is how you write it. So you come over here, you open these two brackets, this square bracket or whatever, parentheses or whatever they call it. I think it's parentheses or in brackets. So you write the numbers inside. So for the x before the y, okay. So 423, 423, comma, we have 286, 286. Now I've entered it for my target star. I'll click enter. So now once once you have entered it, you can now enter the coordinates of your comparison stars. Okay, so this is the style. Okay, this is the format on how you enter it. So how you do that is come over here, you open this bracket, then you come inside, you open another one. Okay, then you come inside that one. So let us write our C1 490, 490, comma, we have 304, 304. Then come outside, you put comma, make sure everything is all right. You open another one, so enter it for your for your for your second comparison star, 415, 415, comma, 343, 343, then comma, you open another one for the third comparison star. So you have 326, 326, comma, 365. We have 365. So I've entered my three comp stars. Somebody might ask, how many comp stars are we supposed to use? Like I said before, you can use between 2 to 10 comparison stars. However, the higher your comparison stars, the better your light curve. Okay, somebody that used 7 comparison stars is better than person that used 4 or 3 or 2. So that is how it works. So after entering it, you click on enter, and once you click on enter, it tells you may move to on the next step. So the next step is the third step. So you come over to the third step. So now you run it to generate your light curve. So you run it. This take much time, maybe 3 minutes. So it will start running. It will start performing photometry on your images. Okay, this you're supposed to do this one by one on the images, but oh, look at the light curve right there. Oh, that's finished. Wow. So and this is your light curve. So this is your light curve of all the images. Each of these data points correspond to the position of the target star in each of the images. Each of these, this. So this is the planet. So this is a curve that shows how a planet is transiting its whole star. And like I told before, I'm going to still give you a lecture on this. Okay, we're going to have a lecture on why this is so. So how many of you got this? How many of you got this light curve? And wow, look at this, the error. Anything less than 1 is good, 0.67%. And this is the what we call the mid-transit time. The mid-transit time. It is in the Julian date. Okay, and this is the how much light was. I mean, the brightness of this the star was diminished. So if you multiply this by 100, it will give you 2%. So it means 2% of the brightness of the star was diminished. So this is called the baseline when the planet has not covered the whole star. So I want to know if you're able to get to this stage. Oh, okay. You were saying something on in the chat. I have not been reading the chat for a while now. I'm so sorry for being late, guys. Oh, don't worry. Don't worry. So, um, how many of you were able to get your light curve like I did? Or were you just watching me? Hello? Yeah, I'm recording it. I'm recording it. I'm recording it. So, but was anybody able to? Was there anybody able to uh, do this along with me?
I just do the first step.
Okay, the step one. Okay, you
Yeah.
stopped. You stopped in step one. Okay.
Yes.
All right, but at least you were watching what I did, right? I mean, everybody.
Yeah.
All
Yeah.
right.
It's
Now we want
it's
to
good.
move to the most serious part, which is step two. So even if we did not uh, do what I did in this first step, okay. Sorry, in this first stage. Oh, what am I even saying? I mean, this beginner stage. Do you understand? Make sure you join me in the second part because the second part is the most important. Okay. If I'm running too fast, please call my attention. Do you understand? So this is what we are doing, generating light curves. Generating light curve like this. So this light curve is a light curve of a planet. Assuming that you are observing a planet, okay, okay, transiting its whole star. You know, common sense will tell you that the brightness, the overall brightness of that star is going to diminish. Do you understand? So, but if you are doing that with your naked eye, you know you wouldn't be able to notice it until you use some special equipment like telescope. Just like the eclipse, this evening eclipse. So it's a partial lunar eclipse. If you are looking at the moon with your eyes, trying to see how the eclipse is going to happen, the lunar eclipse, you won't be able to find it. Okay, you won't be able to see that until you use a special equipment. That is how it is for this case. Now we are done with this beginner stage. Let me go back to that NASA website. Hope I can find it. Okay. Exotic. Let me go back. Maybe I can go back. So, okay. Let me just close it. I can't go back. Let me leave it. Uh, Let me use this link again. Exoplanet project. Let me go back. Okay. Now, but before I go back, okay, I've gone back already. I believe that all of you have downloaded those images, right? Have you? The practice image. Have you downloaded the practice image? This one?
Yes.
Good. And it is in your download, I assume. It's in your download. And this is the So I unzipped this one. Locate this one that starts with 721 blah 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 blah. I want you to unzip it. Want to use this? Want to use it for this? Want to use it? Want to use it? Unzip it, and once you unzip it, you open it. Okay. There is a folder called car folder. If you open it, it contains, sometimes can contain 3 other files or 2 files. Okay, we call this the darks. We call it the dark files. Ooh, you may not understand what it means, but don't worry. Okay, we call it the darks. Okay, then if you come under you will see the readme folder. I want you to open it so that you can read out some details. So if someone asks you what planet are you trying to analyze, this is where you're going to find it. The name of that star is Tres 3, but the name of the planet is Tres 3b. Hope you understand. So anytime you hear about B, C, after those kind of numbering, it means it's a planet. So just like maybe, let me just say this, maybe just a moment. Okay, let me just use Salma as an example. Oh, she left. Let me use Salma as an example. Now, assuming that Salma is a star, okay, then any host planet that is orbiting around Salma will be called Salma B. Okay, if there are 2 or 3 or 4 planets, we call it Salma B, Salma C, Salma D. I hope you understand it now. So this is the convention for naming stars and the host planets. Do you understand? When we have our lecture, even if I don't know if you have the time, but anytime we have our lecture, I'm going to show you how these things came about. So this is our star, Tres 3. Okay. Now the name of the planet will be what? Tres 3b. So that is the right ascension, the declination, and this is the future. This is the observatory. This is the latitude of or where it was observed. Weather. This is the height. This is the weather condition. Now this shows the rating of the images. Okay. Now imagine that you took your images in a clear night sky. Okay, in a clear night sky, there won't be much troubles with your images. Maybe the rating, the weather rating may be, let's say, 100%. Now compare that with when the weather is so bad, the cloud is not clear. Okay, when it is so bad that there's nothing you can do about it, you can get 0%. Okay, you can get 0. So you can imagine the worst part is 0 and the best part is 100%. So anything between 0 to 100% is the weather rating of these images. So now for our images, typically the weather rating is 96.88. So it means it is what? It is good. Okay, it is good. Sometimes they can be very bad. They can be 20%. They can be 25%. So it means that you may not even be able to find stars in that image. Everything will just look dark. All right. So now we have gotten the name of our star. This is very important. The name of the star we want to analyze. Okay. Now let us go back. Now open your Google Drive. Uh, Open your Google Drive here. Okay, this is my Google Drive. Then in your Google Drive, now go over to new. You click over to new folder. Okay, we want to load those images in this new folder, and I'm going to call it trace 3, okay, because we want to analyze trace the star called trace 3, okay. So once you have done that, you create. So the folder has been created. You can open it. So this is the folder, okay. We want to import those images here, those 76 images or what they're about here. So how do we import it? So if you are here, you can just right click on your mouse, okay. You will see this. So we want to upload the files. Come over to upload files or file upload. Now go back to where you have your downloads, those images. I'll go over to downloads. So this is practice image. So this is the one I unzipped, okay. So I'll come over here. Now I want to highlight everything except these these two files. This cal, okay. Don't get them in now. Then I'm gonna highlight this one, okay. So hold down your control. So first of all, click Control A. Let me start afresh. You click Control A to highlight everything, but we don't need this. Read me, we don't need it. So if you want to deactivate it, you hold on your Control key in your computer, you click here. Oh, I think I've made a mistake. Let me, oh, wait. No. This is very wrong. Sorry, let me do that again. This is very, I'm not supposed to do this. It is beginning to come in. Oh, that's terrible. Oh, anyway, we can still delete the ones that we don't want. The
Just
images
got
are,
messed up. Yeah.
the images are coming in.
You weren't supposed to upload them all at once, or you weren't supposed to
You
upload
know,
them at all.
the README file, I never wanted to upload the README file and the cal folder, okay? I didn't want to
So, like,
upload them.
wait until they are uploaded. Wait
But
till
I can
they
still
are
I can
uploaded,
I can still
and
delete I can still delete them. Do you understand? I can still delete them.
yeah, just delete me file. Read me mb.
Okay. Hold on. Let me do that. Let me start afresh. Let me start afresh to do it. Delete. I want to. Great. So let me start afresh. So file upload. So you click Control A. I do not want to highlight this, so I'll hold down my control button. Then I'll come over here and click. So you see that. Then I'll come down. I'll come down and do the same. Click. So now I can now upload the rest. So I'll click on open. So they will begin to upload over to my Google Drive. It's coming. Oh, there are lots of messages. People are sending many messages. You know, my computer is connected to my WhatsApp, so everything is just distracting me here. Now, if you observe these files, if you observe these files, you know, if you use your idea of Isaac asteroid search, if you look at the files, okay, you will see PS1 or PS2. Do you understand? Then you will see uh, maybe the dates, isn't it? So that is how fit files are. If you look at a typical fit file, what the first thing you will see there is the telescope. PS1 for asteroid is Penn Stars telescope, okay? But for this one, this is the micro observatory, okay? Then this This Sicilia is this micro observatory is a network of observatories. Okay, it's like a network. Okay, that have different stations. So this Sicilia is just one of those stations. Okay, great. So then we have terrestrial. Terrestrial is the name of the star, like I've told you before, and this is the date, 2015. This is the date it was observed. Images were collected. Let me check if this has finished. Okay, I think my one has finished. My one has finished. Okay, so I'm done. You see that? I'm done. Then open another folder. Open a new folder. Call it docs. Docs folder. Create. So this is the folder, the docs folder. Then you open that docs folder and upload. Go to file upload. Now come over to this Carl. Open it. These two doc folder, those two doc files, you highlight them, then you open it. So they will be loaded in the docs folder. So let me go back. So this is the docs folder, and these are my images. Let me close this. So once you have done that, you have loaded your bullet, but not ready to shoot yet. Okay? You have loaded your bullet. You know, remember in the first stage, this has been done for you. Okay? You just started to do the photometry. Now let's go back to the NASA website. If you go over to the NASA website, you would come over to exotic. Come over to exotic. You scroll down. Now, no, now we want to use the standard, okay? Want to use the standard to analyze it. So you click on standard. So now we are now in the standard, but the standard is a little bit different from the beginners tutorial. It is different. In the beginners, there are there are 3 stages, but here there are 4 stages. Okay, so number 1 is load exotic and mount Google Drive. Okay, now let us load the exotic. So just like we did before, so this is going to take longer than the beginner stage. Just take note of that. It's going to take longer. So I'm going to come over here and click. So warning, this book note was not authorized by Google. Don't worry, just click on run anyway. So it will begin to run. Sometimes it will crash. You do it again. So, but please, are you doing this with me or are you just watching what I'm doing?
I'm just watching now.
Oh, okay.
But I'm taking notes.
All right, all right. Anyway, I'm recording
Yeah,
it.
for me too. I can't do it now. I can't do it now because of the lack of the internet connection. But I'm taking notes
All right,
on the steps and everything.
all right. And I'm also recording it. So after this meeting, I will send you the recording. So it is
Okay,
Yeah, that would be like really really helpful.
okay. So it is importing the Python libraries, all the Python libraries here. So it will take longer, maybe 2 minutes. It will take longer than
I'm
the.
sorry we can't. I'm sorry, like you get interrupted. Is the internet okay there or?
No, yeah, my internet is okay. It takes time, okay? It just naturally takes time. 2 minutes. Sometimes it will just crash, even if your internet is super fast. It's just one problem with it. let's just give it some time. In fact, during this time, I would I would suggest maybe you should check on this what is it? I want you to log into this Slack. I want you to enter the Slack channel now as we are waiting for this to load. I want you to click on this Slack channel and log in. Click on this and log in to the Slack channel. So when you are done, when you have produced your light curve, you can share it with the community. So I've logged in before. Coming. I've logged in before. Okay, continue with Google. Those are the people. See what Exoplanet Watch is up to. Come over here. This is Robs, the founder. So I don't want to do this because I've done this before, but I'm just showing you the way. Let me show you the community here. Okay, I've clicked this. It's coming. It's coming. The Slack channel. It's coming. Let me close this. Oh, it crashed. My load image setup crashed. See that? It crashed. So I have to do that again. Okay. It is normal thing. Okay. It's not because of bad network or whatever. It's just normal. So you do it again. And I'm happy that it crashed. So that if you are doing it on your own and yours crashes, you know that it is just normal, not because you are doing something bad. So it is loading the libraries. There are many messages here. Oh, wow. So many people are reported about the eclipse.
I'm sorry. I want to ask about the second like highlighted thing in the bouquet.io.
Wait. Okay, I think mine. Okay, it has completed. Just hold on a second for your question. You see that? This is the sign to show that it has completed. It says, permit this notebook to access your Google Drive files. You say connect to Google Drive. Okay. Then you connect it. This is my Google Drive email. This is my email. So you come over, you scroll down, you allow it. Once you've allowed it, watch what is going to happen. Watch out. So you have seen the green mark. Although it says 1 minute, but I think it's a lie. It took more than that. So it said you may move to the next step. So we have succeeded. This load image is the second step. Let us load our images. So you come over to this. This is where you always click these buttons. You click it, then it will prompt you to load the file path. It says enter part of the fit files in the Google Drive. I mean the path of where we loaded those images. Okay, and how do we trace it? You come over here, this box, you click. If you click, to bring you several options. We want to navigate to your Google Drive. So you come over, click Drive, okay, and this is okay. Click on my drive. I think my drive. You click on that, and here is the folder, the Track 3 folder. Okay, then you might want to you just click for that one. Look at my files. See that? But come over here. This particular one, you click on these three dots, you come over to copy path. Copy the path, come over here, you paste it. You paste it, you click enter. Okay, then it will prompt you to enter the target name of your exoplanet. So what target name did you see? Can you remember? Enter the name of your exoplanet target. Can you remember the name? Let me close this. Hello? Can you remember the name of the target, the star? Who can remember it? It is Tres. Remember? Tres.
Yeah.
Yeah. So that is what we read from the README file. If you don't know where to find it, it is from the README. So I'm going to write it. It says enter the name of your exoplanet. Okay. So it is Tres B, like I told you. Tres 3B. All right. So once you do that, once you click that, it will begin to search the NASA exoplanet archive to find it, and it has found some information about that star, about that exoplanet. So you can see the targets, the light ascension, target star declination, planet name is this, the host star name is this. Okay. All right. So then enter your ASVSO observation code. So now this is where you enter that observation code that you generated. Mine is MMCC. It is unique for everybody. Do you understand? So once you come to this stage, click on MMCC, click on enter. It will prompt you to enter it again, MMCC, for my observation code. So allow it, so you may move to the next step. Now this step is where you clean your images. Sometimes some of your images may not be clean. I will show you what it means. I have clicked on it. So it is going to bring all my images. I think there are about 76 of them. Okay, would you like to manually manually check image quality? I'll click on Y, yes. And watch out, it's going to break up my images. Look at my images here. So this is 1/67. So this is the first. So if I spot any bad image, I can just delete it. Okay. So watch how I do it. So maybe, okay, this one is good. Okay, I will say keep. Click on keep. It will bring the other one, 2/67. So it's good. I'll keep it. So this is what you do. You inspect all the images one by one. Okay. Even if you do not do this, the exotic will do it for you. But if you do it, you will do much better. Okay. You'll be much better than exotic. So you inspect images one after the other. But I think these images are clean. Okay. But I'm just showing you the steps in case you mentioned that to the NASA group. They might refer you to do it, and you won't get confused. So now in the stage 3, let us identify our target star and our comparison star, like I have done it before. So before you can do that, you must enter the name of your host star here, so that you can generate the star chart. It just gave you this hat P32, okay, but what we have is trace 3. So let me copy it from here. I like to copy it from here. Sometimes if you enter it, it will give you error, but if I copy this one and paste it, it doesn't give me error. So I'll come over here, copy, then I'll come over here and paste it. And let me remove this. Let me remove this. I will paste it. Then enter. Uh-oh. I've clicked on enter. Okay, sorry. I'll come over here. Sorry, not enter. I've entered the name of the hot star. So I'll come over here and click. So it will bring up the star chart. It is coming. So it is pulling the star chart details. Okay, done. Generate ASVSO star chart. Look at that. Great. So this is the star. Don't bother, don't mind what it wrote here. This is the particular star. Okay. Now, if you do not change this, if you do not change the name of the host star and you left it to the previous one, it is going to bring the star chart of the previous one. And you know, the images you have here are not for that particular star. Okay. So this was a mistake I was doing in the beginning. Okay. I don't usually change the initials here, and it gives me the wrong star chart, and I'll begin to have a hard time figuring out the star pattern. So let us figure out the star pattern. So if you look at it, look, observe. Did you see these three stars? Did you see them? Did you see what is going on here? I think you can see a pattern, right?
Yes.
Great. How about this? Look. 1, 2, 3. How about this? 1, 2, 3. Did you see any pattern?
Yeah.
Great. So now focus on the center. Focus on the center and the surrounding stars. Look at what is going on here. I can see three stars that are curved, like a kind of a curve there. So can I see that curve? I think I can see the curve. Look at the curve. So this is where, so around this region is where the target star is. Okay, around this region is where the target star is. So I want to zoom in. I like to use the wheel zoom because I have the external mouse with me. But even if you don't have it, you can use this other one. They are the same. Okay, because you don't have it, let me use it. Let me deactivate it. Let me use it. So I'll come over here and I will hold on. Sorry, I will hold on to the. Who is calling me? No way. Okay, I will hold on to the left click mouse. I'll hold it and wow. So look at those stars. Look at how curved they are. They are curved. And here, they are also what? Curved. Why am I concerned about this? The reason why I'm concerned about this is because they are closer to the target star. So now, can you spot the brightest of them there? So look at the brightest star there. This one, I guess. Now, if you project, if you project, if you make a projection, whatever that lies in front of it becomes the target star. So if I project, maybe it's this one. I think it is this one. So that is so this is the particular star that has a planet orbiting about it. Do you understand? It is that particular star, this particular star that has a planet orbiting around it. So I have identified it. So you copy out the coordinate. So the the target star T, the x coordinate is up not 209, 209, and the y is 219. So for now, I have gotten the coordinates of the target star. I have to get the coordinate of the com stars. So what are the com stars? That bright star is a com star. Do you realize that? Okay. There are many com stars around it. There are many com stars. I want to use the ones that are closer to it. There's a star. Hold on a second. I think it is this star. Please. Oh, wait. Okay. Okay. Closer to our target star is a star that is closer to it, and I can identify it. This star, this is a come star. So I'll copy it. So to identify the target star and the comparison stars is a great skill. Okay, if you are not getting it right the first time, you will get it right as you proceed. Oh, I've lost it. Okay, let me trace it again. This one. No, that's our. This is okay. Oh, this is it. This is it. This is it. Well, 192, 192. Then my Y is 226. Okay. Then C2 is. Now let us look for another target star. Another target star. Okay. Now this bright star is a target star. This one is a comparison. Sorry, it's a comparison star. So the x coordinate is, that is x of that star is 167, and the y-axis is 201. So I have found two com stars. Okay, like I told you, to improve the accuracy, of your measurement, okay, you have to add as many com stars as possible. Okay, no, we are just training. There's no way I can start looking for 10 com stars here. It's going to take us a lot of time, but you can use this process to identify your target star and your com stars, and you write down their coordinates. I hope you understand. So let us enter those in our in our in our table. So let me enter the coordinates of my target star first. So this is 209, 209. Then we have 219, 219. So I've entered this. You click on enter. So to bring you another table, you open it. You come inside, open it again. Oh, mistake. You open it again. You come inside. So you enter your C1 192, 192. Okay, the other one is 226, 226. Okay, so you open another one. Okay, we have 167, 167, comma. Oh, mistake. I have made a mistake. I have made a mistake right now. That's supposed to be inside the bracket, so that's a mistake. So 167, 167, 201, 201. All right, so I think I've entered it correctly. Okay, so that is for my C2, and that is how you enter for more and more comstars. So once you have done that, you click on enter. So it will prompt you to move to the next step. So that next step is now to run the exotic to generate your light curve. So it will take between 3 minutes to 15 minutes. Okay, so it takes time. So you click there, and it begins to. So it will prompt you. Uh, Observe. It will prompt you to enter yes or no something. Okay. Would you like to comparison added automatically? So just click yes. Yes. Why? And allow it to start running. Like I said before, this process is called reduction. So anytime you hear astronomer talk about image reduction, it means they are trying to perform photometry on those images. Photometry. So it's a starting reduction process. So it is starting now. So to take time because you have a lot of images, it is going to be performing reduction on each of those images. So, and you have to be patient. You have to be patient here. So you may ask me your question at this point as we are waiting for this to finish. You may ask me your question. Hello? Hope you are still there. Okay. You can ask me your question. Any questions?
For now, no.
Okay.
Okay.
Have you entered the Slack, the NASA Slack channel?
Yeah, I entered.
Okay. So I'm gonna show you how you will introduce yourself there. Okay. I'm gonna show you how you do that. So as we are waiting for this to finish, I want to also show you some other things. Now, what I'm using to show you this is called um, practice. Okay, I'm going to show you how to submit it, but I'm not going to actually do that because these images are for practice. Okay, but assuming you now after learning it, maybe after watching this video again, and you want your own images, how do you get your own images? How do you do that? So how you do that is this. Come over to that link. That link. No, no, no. This is still loading, so we can't just wait for it. We can't just be looking at it. So you come over to that Exoplanet Watch website again. So now, now you are here. Come over to how to participate. Okay. So you click on how to participate. Okay. All right. It's clicked. Then you scroll down. Okay. So it says no telescope, no problem, because most of the people that are contributing to this research have their own telescopes. Okay, but even if you don't have, NASA is going to give you. So you don't need to have your own telescope to participate in Exoplanet Watch. Submit your email to check out exoplanet observation data from robotic telescope that can reduce and submit to this. So you click over here, learn. So if once you click over that, so how to participate, there are many instructions here. Just continue scrolling down. Okay, then here you will enter your email. So if you enter your email, you check on this. Let me enter my email. So just do that. If you do that, you're going to receive you're going to receive an email right now. So, but you have only 2 weeks to analyze it. I mean, to perform data reduction, okay? Like what we are doing tonight. Just have 2 weeks. So every 2 weeks, you do the same thing. You come over here, you request for data. Every 2 weeks, okay? And make sure you are always, following, information about this project, for motivation in that Slack channel. It is very important. No, so after requesting your images now and you have learned how to perform this data reduction, you produce your light curve, okay? Now, after producing your light curve, okay, this is still, I think that's finished. Has it finished? Let me check. Okay, it is performing on each, so this is 59 of 67. Okay, it's almost finished. It's almost finished. So it is performing a data reduction on each of those images, each of them. So this is now easier because you are using a computer code. Before Exoplanet Watch, students used to do it one by one, like performing the data reduction on each of the images one by one, and it is very boring and very tedious. I've done that before, and I can tell you it is very boring. So I think that's finished. Okay, computing best comparison start, aperture, and sky annulus. Please wait. Just wait for it. And see the final result. It's going to produce the light curve. It's coming. It's coming. So, how do you feel about this project? How do you feel about it? Is it interesting to you?
Yes, interesting, but a little complicated than the first project. Lot of
Yeah,
parameters.
exactly. No, many links to click this. Yeah, but once you get used to it, you see that it is very beautiful and very much easier. Very much easier. This is research, okay? If you state this in your statement of purpose in your essays, maybe you want to apply for master's or PhD, and you state projects like this, you have done things like this, it shows that yeah, you really love astronomy, and you have been helping yourself doing some research works. All right, maybe it is taking some time. Maybe we should do some other things because I would like to show you how to submit it. I would like to show you how to submit it. So submit your light curve. Okay, it's almost about great. Look at that. Oh, it's coming. Oh, the light curve should be ready. Light curve. Oh, a lot of things. Oh, oh my God, a lot of things. Okay, let me come down a little bit. Okay, there is more. It's still generating. End of reduction process. Great. So output file saved. End of reduction. So where is my, okay, look at our light curve. Look at our light curve here. So look at our light curve. So this is the patch of the sky. This is our target star. This is one of the comparison stars that we use. So we are going to submit this. We're going to submit this image. Okay? And I'm going to show you where you're going to find it. And this is the light curve. This is the light curve of our of our star. So if you multiply here by 100%, it will be 1.99, okay, which is approximately 2%. So you can say that 2% of the brightness of the star was reduced. So and this is 1.65, okay, like I told you, anything less than 1 is good. So the reason why we got this is we did not use a lot of comp stars. Assuming that we use up to 5 or 6, you see that the error, this is the error, will be much reduced. Okay. So, and now this is the period, the mid transit time. This is in Julian date. If you want to convert this to the normal date, our normal date, you can, there's a link there which you can use to convert it. So submit light curve Julian date calculator. If you want to calculate it, if you want to change it, want to really know what it means in our own time, you click over here and you enter it. You don't approximate. Enter it all the way till here, and then it will convert it for you. So what we are doing here is to improve upon the period. The most important thing here is this period. Do you know why? Because about 10 years ago, NASA launched the TESS mission and the Kepler mission to study exoplanets. So they did quite well in finding exoplanet, but they could not get the correct periods. Okay, there were errors in the periods of some of the planets they discovered. Okay, and now we have the James Webb Space Telescope, and we are going to launch the Nancy Grace Telescope very soon. And those telescopes are very expensive. Okay, the James Webb Space Telescope is about $10 billion, and it is expected to last for about 10 years. So if you divide that, you would notice that for 1 second on the James Space Telescope is about $60. 60. So if you want to point it to a planet, to a star that has a planet, you have to make sure that you know where you are pointing to and know the exact time you are pointing to. You don't have to you don't have to just face the telescope there and be waiting for the planet to come out. So you have to know exactly when it is coming out. Just like we have this meeting right now. Okay, we said that this meeting is by 8 o'clock. Okay, so it means that if you join 15 minutes after we started, that means you might have missed some things. So you can imagine that as maybe the planet has started to transit the star. Okay, the planet has started transiting the star. So it didn't really get the baseline, this baseline. So maybe you will start from here when it is already transiting the whole star. How about maybe pointing a telescope to the whole star, waiting for the planet to come out? Maybe waiting for about 2 hours or 3 hours. That is uncalled for. Okay, so you have to know when and where you are pointing the telescope to. So we are helping to improve upon this time. So many people are going to be analyzing the same image. Okay, like now here we got 1.65. Another person might get 0.1 this, no 0. Another person will get 2 points. So by the time everybody got uh, different uh, parameters, different numbers, they will use it to improve upon the next missions of the James Webb Space Telescope. So that is the reason why we are doing this. We are not actually discovering new planets. We are actually improving upon the periods. So if you want to, you don't need to download this. I'm going to show you where you're going to download it. Now, come over to your drive. If you come over to your drive, you will see a lot of files that have been generated. Bad images. Okay, let me just go back to my drive. So this is the folder you created. Remember, this is the folder, this stress3 is the folder you created, and this is the folder Exotic created when it was running the program. So if you open it, you're going to see a lot of files. Okay, this is your light curve. This is your light curve. So this is the one you share with the rest of the community, with everybody. Okay, this is your light curve. You can download it if you want. So it is in PDF form and PNG form. Okay, this PDF form is mostly used for papers, for research papers. Okay, then you have this file, this text file. This is the file you submit. This is the file that contains everything. With these details, you can reproduce those light curves and everything. Although you may not understand what is in here, but with this you can reproduce all the information. So this is the details, all the generated information in what you just did. Okay. So you are going to submit this. You're going to download it. Okay. Let me pretend to download it. So I'm downloading it now. Okay, they're scanning it for virus. It is going to download. Okay, I think it's beginning to download. Then let me go back. If you come over to this temple, you will see more other files, but the one that we need here is this field of view FOV. So we have the PDF and the PNG, PDF and PNG. So they have different stretching scale. We have the linear stretch, linear. We have the log. Just open it, or just open one of them to see what is inside. Some of them are fine, some of them are not fine. So you submit the one that is fine. Look at this image. This one is a linear stretch. So it shows your target star and the configuration star. So you can move to the next image. Oh, you see that this is a bad. No, you can't submit this. Can't really. So this is the. Oh, let me do that again. PNG. So this is very bright. So if you go over to the next one, this is not bright. Okay. So let's keep checking. This is not good. Okay. So this is manageable, but the first one we saw is good. So this is how you check each of these field of view images. Okay, this is so beautiful. This is the PDF. I love this one. Let me view the PNG. Okay, see that? So I can download this. So these are the text file and this one are the two I'm going to submit. Now, how do you submit your report? How do you submit your report? To submit your report, go over to that exotic. You will see submit your light curve to Exoplanet Watch via ASVSO. So you click. So Living Collab, just go over here, click on this link. So this is where you submit. So Exoplanet database submit. Okay. So this is where you upload the form, and this is where you upload that image, that field of view image. But before you do that, you haven't filled in the details about the site and the equipment. The site and the equipment. And you need to do that. And how do you do that? You come over to here, click on site and equipment. So this is you have been signed in, observation code. Oh, all right, this is for the account that I used. All right, so this is the site and this is the equipment. Okay, if you click here, you will fill in the site information, and if you come over here, you will fill in the equipment. But what do you fill in? What exactly do you fill in here? So if you come over to the NASA website, okay, you click on how to participate. That is how we got here. So this arrow should show you. So then you come over to here. Here, you see it is highlighting. You click it. So now you can copy those details. So look at the details, the site and equipment details. Look at that. This is the equipment. I think the site is up. Okay, this is the site. Okay, this is the site. My site, you write micro observatory, latitude this, longitude this, altitude this. This is what you enter in my site. This is what you enter. Okay, not this one. This is what you enter in my site. Then under my equipment, so you come over here again, you scroll down. So you enter these numbers under my equipment. After entering them, you click on save. And once you do that, those information will appear. Once you do that, those information will appear uh, when you want to submit your observations, your light curve, and your details. Let me go back. So when you do that, then you come over and select the site and the equipment. Then here you upload your text file, that text file that we downloaded, and the field of view image that we downloaded. After doing that, you click on accept the policy, this one, you just take it, then you submit. And that is the end. So I believe, sorry, the process is more tedious um, than the asteroid search, but believe me, this is very, very exciting. So I want you're going to watch the video. and I'm going to do a separate video on the lecture part. Okay, I'm going to do a separate video on the lecture part so that you can watch it. After watching it, you can, you know, balance it with the training, and everything will just be complete. So I think that is the end of my lecture. Any questions? Any questions? Hello? Great, great. Thank you. Check here. Okay, many, let me start from the beginning. Can you share, can you share, ask me on WhatsApp?
No, it's just for the link. I already shared with him.
The link to what? Is it the word, the document, the shared document?
Yeah, the link of the
No,
document.
yeah, yeah.
Okay,
She's
okay.
I just asked her to share with me again the documents. Yeah.
Yeah, and please, you
Marcel,
have to
can you
save
hear
it.
me?
You have to save it, okay? Maybe pin it to the tab so that you always have it.
Yeah, yeah, yeah. Yeah, Marcel, can do you hear me?
Yeah, I can hear you.
Yeah, can you leave me your WhatsApp contact so I can ask you a couple questions while I'll be doing these tasks because this is confusing to be honest.
But first of all, uh, I want you to sign in onto that NASA NASA Slack. It is important, honestly. Okay.
Slack.
Yeah, Slack channel. There's NASA Slack channel.
Uh, I've been using Slack by an account from an entity. But like, if I want to use Slack individually, do I need a license or something, or is it's free?
Okay. Slack is like, let me just say WhatsApp, okay? There are many groups on WhatsApp. So there are many channels for different organizations. So even if you are using it for a particular organization, you can
Hmm.
use it for another organization. Yeah. So you can.
Yeah,
You
cool.
can use it. I have set my number here.
Yeah, yeah. I'll contact you, of course.
Okay.
So, Marcel, just want to say thank you so much for for demonstrating these great tools, and thank you so much for this lecture.
Yeah.
And I guess we'll stay in contact
All right.
for upcoming lectures or projects. And it's a great time working with you and asking you and sharing with you and using your great vocabulary in astronomy. I gotta say, it's a pleasure working with you.
Yeah, it's a
And
pleasure
thank you
too.
so much for your time.
All right. All right.
All right. So
All right. Thank you, everybody.
we'll be off, guys.
I'm going to send you
Thank
the
you so
link.
much.
I'm going to send you this link very soon. Before tomorrow, I'll
Okay.
send it. All right.
So bye everybody. Have a great night and see you soon. All right.
All right. Good night.
Bye, everyone. Thank you so much, Marcel.
Uh, all right.
It's a
Thank
really
you.
interesting project.